Hey guys!
What would you do if we told you that one diet actually works better than the other?
Or if your age or gender changes, how much weight you lose.
Today, we're not just talking about diet trends. We're digging into real data from 90 participants who tested them.
Stick around because we're breaking down the stats, and honestly, I kind of want to try one of these myself after what we found.
Same.
We got our hands on a dataset with 90 participants, each assigned to one of the 3 diets over 6 weeks.
We had info on their gender, age, height, starting weight, and ending weight. And from that, we calculated weight loss from each participant and grouped them into different diet types, age, and gender. We created 3 hypotheses, and here's what we wanted to find out.
Number 1, do the 3 diets lead to different average weight loss results?
Number 2, does your age group affect how much weight you lose?
And number 3, does the combination of your gender and diet matter?
To test our ideas, we use something called Way ANOVA. It helps compare the average weight loss across groups. So, what is a Way ANOVA? A Way ANOVA is a hypothesis test. And what does the Way ANOVA test? An ANOVA tests whether there are statistically significant differences between 3 or more groups. More precisely, it is tested whether there is a significant difference between the mean values of the groups. We used the statistical method of ANOVA to test all of our 3 hypotheses. Now, after we conducted the Way ANOVA statistical analysis in Excel for each of the 3 hypotheses, let's go ahead and dig into our results.
For hypothesis 1, the p-value was 0.00000037. That's way lower than 0.05. So,
we rejected the null hypothesis. There is a significant difference in weight loss between the diets.
And the winner, diet 3, highest average weight loss, most consistent results.
Now you may be wondering, why do we use 0.05 in ANOVA and most hypothesis tests? Well, the 0.05 is a significance level, often written as alpha. It represents the threshold of how much risk you're willing to take of making a type 1 error. That is, rejecting a true null hypothesis, or a false positive. In simple terms, if your p-value is less than 0.05, you're saying that there's less than a 5% chance that results happen randomly, so it's probably real. In our case, when using Way ANOVA, we calculate an f-value and get a p-value from it. If the p-value is less than 0.05, we reject the null hypothesis and conclude that there is a statistically significant difference. If the p-value is greater than 0.05, we fail to reject the null hypothesis. Any difference you see is probably just random variation. This is why we rejected our hypothesis number 1, because there was a statistically significant difference, which means it wasn't just by random chance. Now let's go ahead and get into our hypothesis 2 and 3. For hypothesis 2, which was age differences, the p-value was of 0.44. That is higher than the 0.05.
So, we couldn't reject the null hypothesis. Age didn't make a significant difference in weight loss in this study.
But hypothesis 3?
That really surprised us.
The p-value was of 0.0081.
Which means,
yes, gender and diet combinations do lead to different results in weight loss. After analyzing hypothesis 3, we found out that the combination of gender and diet clearly affected weight loss outcomes. Female participants on diet 3 lost the most weight on average, 5.86 kilograms, while in comparison, the highest average weight loss among male participants was 4.34 kilograms on diet 3, which is still lower than the average of females on the same diet. This suggests that gender, in combination with diet, plays a significant role in weight loss. Of course, the study had limitations. It only lasted 6 weeks.
And it didn't account for exercise, calorie tracking, or other lifestyle stuff.
In the future, we'd love to explore longer programs, including activity levels,
and maybe even try diets ourselves.
Time for some rapid-fire trivia. Question 1. What does a p-value less than 0.05 mean? A. The results are random. B. The null hypothesis should be rejected. C. The diet tastes bad. D. ANOVA is broken.
If you picked B, you're a stats superstar. Question 2. ANOVA is a test that helps us A. Compare means across groups, B. Count calories, C. Choose a salad, or D. Make charts look cool.
If you choose A, ding ding ding, ANOVA compares group averages to see if the difference are real or just by chance. Question 3. If our p-value is greater than 0.05, what do we do? A. Reject the null hypothesis. B. Accept the alternative hypothesis. C. Fail to reject the null hypothesis. Or D. Order pizza.
C is the right answer. We failed to reject the null hypothesis, meaning the differences probably aren't statistically significant. Did you get all 3 right? You passed our stats challenge.
Nice job, class. We hope our video helped you learn more about Way ANOVA.
Thanks for coming with us on this data dive. And remember,
Before you start your diet, run some statistics tests first.
see ya!